So welcome back to example 3 in our notes for triangle trig. And in example 3, we have x as our angle, and we're given the side opposite of x, and that's 18. And we're also given the length of the hypotenuse, which is 36. And we know from the acronym SOHCAHTOA that the sine is the ratio of the opposite over the hypotenuse. So then I can say that the sine of my angle x is equal to the opposite, which is 18, divided by the hypotenuse, which is 36. Now, to get the x by itself, we need to do the inverse of the sine function, and the inverse of sine is the arc sine. So we're taking the arc sine of both sides. So we're going to take the arc sine of the left and the arc sine of the right. So on the left, we're taking the arc sine of the sine of x, and on the right, we're taking the arc sine of 18 over 36, which is 1/2. Now, the inverse of sine and sine, those cancel each other out and leave us with just an x. And so the x is exactly equal to the arc sine of 1/2. Since we're working with triangles, we're going to be using degrees as our units. So we want to go to the mode and make sure that we're in degree mode. And then we're going to, second mode. There we go. So in degree mode, we're going to do second sine to get the arc sine. Remember that sine with a little -1 in the corner, that means sine inverse or arc sine. And we want to evaluate the arc sine of the quantity 1/2, so that needs to be inside the parentheses. And then when we press enter, since we're in degree mode, the answer is going to be given in degrees. So our answer is 30 degrees. And don't forget your units on your answer, so that we can distinguish between degrees and radians when we start working in circles. So x is equal to 30 degrees. Okay, go ahead and pause the video, and I'd like you to try examples B and C on this page, and when you've worked them out, go ahead and resume and we'll go over the answers together. Okay, in example B, the angle x is what we're looking for. We're given the length of the hypotenuse, which is 92. And this time we're given the length of the side adjacent to the angle, and that side length is 7. So adjacent and hypotenuse is the cosine function, the CAH. Cosine is adjacent over hypotenuse. So x is equal, or cosine of x rather, is equal to the ratio of 7, which is the adjacent, over 92, the hypotenuse. Then we do the arc cosine of both sides to get x by itself, and x is equal to the arc cosine of 7 over 92. Which in degree mode, rounding to 4 decimal places, is 85.6363 degrees. Okay, then in example C, we're given the side opposite of the angle x, which is 13, and that's an O, opposite. and we're given the side adjacent to the x, which is 12. And the ratio for opposite over adjacent is TOA, tangent is opposite over adjacent. So the tangent of angle x is equal to 13, the opposite side, over 12, the adjacent side. We take the arctangent of both sides, and x is exactly equal to the arctangent of 13 over 12, which is approximately 47.2906 degrees, rounding to 4 decimal places. Okay, so go ahead and try this one on your own. You want to solve the right triangle where you're given two side lengths. Side A is 8 and side C is 14. And remember, in a right triangle, C is the longest side, the hypotenuse. That's always opposite the right angle. Okay, so if I were to make a sketch of a right triangle, then opposite my right angle would be the C, which is 14, and I can make either angle A or B, but then the side opposite those capital letters for angles have to be the lowercase letters for the side. So opposite capital angle, capital A angle is lowercase letter side A. Opposite capital letter B is my angle. I have my lowercase letter b, and that one I don't know yet. And then lowercase c, my hypotenuse is 14. That's opposite the right angle, capital C. So if I know two sides in a right triangle, I can find the third side using the Pythagorean theorem. So a squared would be 8 squared plus b squared is the one I'm looking for, is equal to c squared, which is 14 squared. So I would subtract 8 squared from both sides, square root both sides to get rid of the square, and my side b by itself then, and it would be plus or minus, but since it's a triangle, I'm going to just keep the positive, is going to be 14 squared minus 8 squared, and that's all under my square root. So in the calculator, I'm going to enter that quantity, 14 squared minus 8 squared, and that's 132. So b is exactly equal to the square root of 132. And I want to simplify that radical completely. So I'm going to break down my 132 in a factor tree. So 132 is 2 times 66. 66 is 2 times 33. And 33 is 3 times 11, which isn't going to give me another pair of values I can pull out. But I could pull out a 2 since I've got two 2's. So b reduces to 2 square root of 33. So I can put that up here, 2 square root of 33. And that's the exact value of my side B. Now I want to find angle A, and I know if this is my angle that I want to find, I know the length of the side opposite, and I know the length of the hypotenuse. So to find angle A, I could use the sine. So the sine of angle A is equal to the opposite, which is 8, over the hypotenuse, which is 14. I'm going to take the arc sine of both sides to get A by itself, and A then is equal to the arc sine of 4/7 when I reduce that fraction. And in the calculator, arcsine of the ratio 4/7 is approximately 34.8499 degrees. So A is approximately 34.8499. Okay, then to find angle B, I have some choices. I could do sine again if I wanted to use that radical, or if I want to use a different trig function. I know the adjacent and the hypotenuse, which would be cosine. I could do tangent. Since I know all three sides, I could do any of those. So I'll go ahead and use the cosine just to keep my numbers simple. So the cosine of angle B is equal to the adjacent side 8 over the hypotenuse 14. So taking the arc cosine of each side, angle B is exactly equal to the arc cosine of 4/7. And when we put that in the calculator and evaluate, arc cosine of 4/7 is 55.1501 degrees. Oh, whoops, 55.15, there we go, 01 degrees. Okay. Now, another thing that we could have done was sort of a shortcut. If you're in a right triangle, you know that your first angle has to be 90 degrees, and there are 180 degrees in the whole triangle, right? So 180 minus 90 degrees for your right angle leaves 90 degrees left. If I subtract the angle A that I just found, 34.8499, notice I get the angle for the cosine of B. If I had instead found the angle B first, then 90 minus 55.1501 would have gotten me the measure of angle A. So you don't have to use two trig functions to find your two unknown angles when you're given two sides. You could use that triangle sum theorem. And the triangle sum theorem says that all the angles in the triangle add up to 180 degrees. It's a right triangle, so we know that the two remaining angles, angle A and angle B, they have to be complementary angles, two angles that add up to 90 degrees. And that leads us into what we're going to learn in example 4. Okay, so before we take a look at example 4, we'll go ahead and try the secret question for this lesson, which is on solving right triangles. To solve a right triangle means to find all of its unknown sides and angles. So in problem 1 of the secret question, you're given two angles and one side, and you want to find the remaining angle and two sides. Remember that triangle sum theorem we just talked about, that all the angles in a triangle add up to 180 degrees. That's a big hint. Then in problem 2, you're given one angle and two sides. That's like the practice example we just looked at. a moment ago. So you're going to show your work on scratch paper and upload that to Schoology as the last page in your notes, and then you'll enter your answers into the Schoology assignment for this lesson so that they get checked and you know right away if you got them right or need to ask for help.